today we're going to take a look at roots and radical expressions, and specifically the nth root. Now, we've talked about square roots many times, but it actually goes beyond a square root. There are other roots. So when we talk about powers, like we did in our polynomial chapter, a to the nth equals b, if I want to undo that power, I need to do a root or a radical. And so I need to do the nth root. So if this was an a squared, this would be a square root. But it goes beyond that. If this was an a cubed, this would be a cube root. And that number that's sitting there, that root or that radicand is called, or radical is called the index. Okay, whatever index we're trying to do, a third root, a fourth root, a square root, whatever it might be. Now you might be wondering, we've never had a number there before. How do we know it's a square root? If there isn't a number there, it's automatically a square root. But as soon as we put something different, third root, fourth root, fifth root, that number is going to show up right there. That's called the index. The thing that we're actually taking the root of, in this case the b, that's the radicand. Okay, so that's just the terminology you may see them use. But when we talk about roots, just like when we talked about powers, they fall into two categories. They fall into the even roots or the odd roots. So if our index is even, notice there's a lot more rules. Think about square roots. If b is positive, there's actually two possible answers. The positive one that we're used to, okay, this one is called the principal root, but there's also a negative one. So if you think of my example down here, the square root of 25 is 5. That's called the principal root. That's the one we tend to think about. But negative 5 squared also gives me 25. So the square root of 25 could also be negative 5. So it actually has two answers. Something like a fourth root, which is even, has two answers. The principal root, the positive one, and then the negative one, in this case negative 2, 2 and negative 2. So even roots have two answers. Now when we take a look at the odds, when n is odd, the root is what it is. There is not two answers. There's not a principal root and another root. There's only one answer. So if I wanted to do the third root of 27, it's 3. And it's 3 because 3 times 3 times 3 is 27. So the third root of 27 is 3. The third root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 is negative 8. It only has one answer. So the odds are easier. Whatever's here, it has one answer, either a positive or a negative, not both. The even's going to have both, and we're going to have to indicate that as we go along. So let's take a look at some examples, see what we can figure out. I started with some square roots, just to get back in the swing of things. So the square root of 16 is 4, the square root of 81 is 9. When I put them together as a fraction, you just do them as pieces and put them back together. Now here's a third root. So the third root of 1 is 1. The third root of 27 is 3. Now if you're having a hard time with these, or it's a little confusing, think of it this way. 1 cubed and 3 cubed, and we're cube rooting that. So our cube root and our cube is going to cancel each other out, and that's how I got my 1/3 for an answer. Now if I have the cube root of a negative number, it's okay. We can't take a square root of a negative number, but we can do odd roots. So the cube root of negative 1,000, I'm trying to find something times itself 3 times that gives me that negative 1,000. Turns out that's negative 10. Now let's look at a fourth root. Now I'm looking for something times itself 4 times. 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. So the fourth root of 16 is definitely 2. The fourth root of 81 is 3. Now, the fourth root's kind of unique because it's actually square rooting twice. So the square root of 16 is 4, but the square root of 4 is where the 2 comes from. The square root of 81 is 9, square root of 89, or 9, is 3. So I'm actually square rooting twice. Now the thing that I forgot is this has two possibilities. It could be positive, could be negative. Same thing back up here at my start, and that's because these are even roots. Okay, if it's not there, it's automatically a square root. If the index here is even, we have to have them both. Odd ones, they only have one answer. It's either positive or it's negative, but it's not both. Fifth root, it's odd. That index is odd. It's only going to have one answer. Fifth root of 32 is 2. If I have decimals, you have to think of these in their proper terminology. Most people look at this and go 0.04, which doesn't mean a whole lot. But if you think about what it actually is as a number, this is actually the square root of 4 100ths. I can do the square root of 4, it's 2. I can do the square root of 100, it's 10. I get 2/10. Now if I want to stay in the same format as what they have here, think about the square root of 4 is 2, but we're going to lose one of these decimals. That's where the 0.2 would come from. And again, because this is a square root and even index, we have to have the positive 0.2 and the negative 0.2. It does have two answers, the principal root and the other one. Now let's look at some that have variables in them. So now let's take a closer look at some of these roots and include some variables. But before we jump in, we have another definition here when we start talking about roots of powers. Okay, notice that these two powers and this root, the radicals, are the same. The common thing to do is just cross them out and just leave it with a, but it really boils down to that whole, is it odd or is it even? So if we're talking about an odd index here, an odd power, then a is what it is. So we can just cross them out just like we expected. But if n is even, if we're talking about a square and a square root, or a fourth power and a fourth root, then that a actually loses its sign. Okay, and here's what I mean by that. Here's a square root and a squared power. Those two things are going to cancel each other, but the answer is not going to be -7. We're going to actually take the absolute value of that. Because think about this, if I would square -7, I get 49, and the square root of 49 is both positive and -7. It has two answers. We're going to take the principal root, the positive one. So this is actually going to be 7. Now it's not that way with the odd ones. With the odd ones, the power and the root cancel each other, and I get whatever is sitting here. But where it gets a little tricky is when we start talking about variables. Now we can definitely do the square root of 16, that's no problem. And if you want to think of this as 4 squared, and the squared and the square root cancel, and that's how we get the 4, you can certainly do that. So the numbers didn't change, but now all of a sudden we have this x to the 8th. We have different ways of handling this. For some people, they pick up on a pattern here real quickly with that 8. But I'm going to write this out. I'm going to write this out as x squared, x squared, x squared, and x squared. And I'm square rooting all 4 of those things. I'm square rooting each part, just like I square rooted the 16. So if I do that, I'm going to get my 4, and I'm going to get an x out of each one of these. But I'm going to go ahead and put those x's back together, and I actually have 4 of those x's. Now notice I didn't square root the 8. That's not how this works. I square rooted squares. So I thought of these as squares to make it a little easier. So let's take a look at this one. The square root of 81, I can do that. This I can write as a couple of x squareds, and I picked squareds because they're square roots. So square roots and squares cancel each other out, So I have a couple of x's here. I actually have 2 of them. But what's going to happen if I talk cubes? Now I have to think of these variables as powers of 3. So this is a cubed, and a cubed, b cubed, b cubed, and b cubed, and I'm going to cube root each piece. Cube root here, cube root here. You can see what I'm doing. So I'm going to get an a and an a, and 3 b's. That's an a squared and a b cubed. Now, if this makes sense to you, this is going to work. Think of it in terms of cubes or squareds or whatever you're doing. But there is a quicker way if you can pick up on the pattern. Think about the power here of being 8 and the root being 2. 8 divided by 2 is where that 4 came from. Now, I can't take 16 divided by 2. This isn't the numbers. This is for the variables. Up here, 4 divided by 2, that still worked. 6 divided by 3 and 9 divided by 3 still works. So if I can use that pattern, 12 divided by 3 would leave me with a to the 4th. 15 divided by 3 would leave me with b to the 5th. If that makes more sense, then use that idea for simplifying your variables. So if I take that a step further, and I'll do this both ways depending on what you decided on, 8 divided by 4 means this is x squared, and 12 divided by 4 means that this is y cubed. So if that makes sense to you, go with it. If you like breaking it down, this is going to be x to the 4th and x to the 4th. This is going to be y to the 4th 3 times. And when I 4th root each part, I get an x and another x. That's where the x squared comes from. I get a y and a y and a y. That's where the y cubed comes from. So whichever method makes sense to you, I would go for that. Personally, I'm a fan of dividing these out. I feel like it goes quicker, but it doesn't mean it's the only way that can be done. Even with bigger powers. Here, I've got 5 x's, but I want to break it down by the index of 5. I'm going to have an x. I have 10 y's. I'm going to put them in 2 groups of 5. That means I'm going to have 2 of them left. But that's not how we do the numbers in front. The 5th root of negative 32 is negative 2. I got to keep my numbers and my variables straight. There's my final answer. Now you'll notice we didn't put the plus and minus in front of these evens. They're looking for principal roots. Okay? If they don't specify and say find all answers, they're looking for principal roots. Principal roots on those. We only have 1 answer on the cubes. Principal roots here. Are there 2 answers? Sure, there certainly are. We're working on principal roots because now we've got those variables to deal with.